Okay, let's just dive right into this explainer and explore the massive, unseen infrastructure that literally keeps our modern world flowing. Every time you turn on a tap, take a shower, or run your washing machine, you're tapping into the sprawling, incredibly complex network. But because most of this infrastructure is buried underground or tucked away in industrial zones, we rarely think about its sheer scale. Well, today, we're going to change that. We are going to decode the invisible empire of water utilities by looking at exactly how these massive operations are measured and quantified.
It's a massive challenge, isn't it? I mean, how do you actually quantify something so vast and largely buried beneath our feet? If you want to know if a water utility is operating sustainably, efficiently, or responsibly, you first have to understand its size. You really can't compare a utility serving a small rural community with one serving a sprawling metropolis unless you have a standardized baseline. And that is exactly where the SASB standards come in, giving us the precise tools and metrics we need to measure this invisible empire.
To understand all this, we're going to break down the anatomy of scale. 1. The scale of water utilities. 2. Counting the customers. 3. Sourcing and delivery. 4. Treating the wastewater. And finally, 5. The hidden underground network.
Let's start with Section 1, the scale of water utilities, and how we establish a baseline.
So the crucial thing to grasp here is that before we can compare sustainability efforts between two water companies, we need what SASB calls activity metrics. You can think of activity metrics basically as the vital statistics of a company. If you're a doctor, you absolutely need to know a patient's height and weight before prescribing medication, right? Same thing here. If you're an investor, a regulator, or just an interested citizen looking at a utility's environmental impact, you need these activity metrics to normalize the data. It lets us compare apples to apples by understanding the sheer physical size and operational scale of the utility in question.
And here we have the actual SASB framework. It lays out 5 specific metrics, labeled A through E, that water utilities must report. This isn't just a bunch of arbitrary data. This is the globally recognized standard for defining scale. So over the next few minutes, we're going to unpack each one of these 5 rows to see exactly what they tell us about our water systems.
Moving on to Section 2, counting the customers and figuring out who actually relies on the water.
Now, what's really fascinating here is how Metric A approaches the whole concept of a customer. A utility doesn't just give us one single grand total. Nope, they have to break down their customer base into distinct categories: residential, commercial, and industrial. Plus, they have to do this separately for the different services they provide, clearly distinguishing between water delivery versus wastewater collection. This level of granularity is incredibly important. Think about it. An industrial customer, like a huge manufacturing plant, puts a very different demand on the system than a residential family home, both in terms of the volume required and the type of wastewater they generate.
But how do they actually count a customer? Keep in mind, you aren't just a person to a utility. Under the SASB standard, a customer is defined as a single, distinct service agreement at a single property. So if someone happens to own 3 different houses in a city, they're counted as 3 separate customers for the utility. This metric ensures that every single property and connection point is accurately counted, which gives us a true picture of the network's overall breadth.
Let's jump into Section 3, sourcing and delivery, where we track every single drop.
This brings us right to Metric B, which looks at the source of the water. Utilities can't just wave a hand and say they pumped 1 million gallons. They have to reveal the precise percentage breakdown of exactly where their water comes from. Are they pulling from groundwater aquifers deep below the earth? Are they relying on surface water from lakes and rivers? Or maybe they're utilizing ocean water through super energy-intensive desalination. They even have to report if they're using recycled water or simply purchasing their supply wholesale from a third party. This tells us a massive amount about a utility's vulnerability to things like droughts, climate change, and raw material costs.
Once that water is sourced, Metric C tracks the actual delivery. And guys, the volumes we are talking about here are just staggering. Utilities must measure the total water delivered in thousands of cubic meters. To put that in perspective, 1 cubic meter is 1,000 liters, roughly the size of a large refrigerator. Now multiply that by thousands, delivered every single day. The utility must report exactly how much of this vast volume went to those specific residential, commercial, and industrial customer groups we talked about earlier. And this includes the whole shebang: the clean drinking water out of your tap, the industrial processed water used in factories, and the recycled water used for irrigation. It literally tracks every drop.
Next up is Section 4, treating the wastewater, the critical cleanup phase. Metric D forces utilities to categorize their cleanup efforts based on the type of sewer the wastewater comes from. This is a super interesting distinction. On one side, you have sanitary sewers. This is the predictable, daily waste coming from our toilets, showers, and industrial drains. On the other side, you have stormwater and combined sewers. Combined sewers actually mix household waste with rain runoff. So when a heavy storm hits, the volume flowing through a combined sewer can spike unpredictably, putting massive strain on treatment facilities. By forcing utilities to report these categories separately, we get a crystal clear view of the environmental challenges they're up against.
And the volume here is just as immense as on the delivery side. Utilities have to report this average daily treatment rate in cubic meters per day. This perfectly highlights the non-stop 24/7 scale of wastewater management. A treatment plant never, ever gets to just turn off. It has to constantly process whatever volume society and nature push into the system, purifying it before it's finally released back into the environment.
Finally, we reach Section 5, the hidden underground network, looking at the physical infrastructure itself.
To truly grasp the physical footprint of a water utility, Metric E uses kilometers to measure the total length of the underground network. For a large metropolitan utility, we aren't just talking about a few miles of pipe. We are talking about tens of thousands of kilometers of pipe, sometimes enough to wrap entirely around the globe, all buried beneath our streets, requiring constant monitoring, maintenance, and eventual replacement.
Under this final metric, utilities must explicitly report the distinct length of both their water mains and their sewer pipes. The water mains represent the pressurized delivery network, bringing clean, safe water right to your door. The sewer pipes represent the gravity-fed collection network, safely carrying the hazardous waste away. Knowing the exact length of these distinct networks really helps us understand the massive capital investments required just to keep the whole system from falling apart.
And that brings us to the ultimate takeaway from this explainer. The SASB activity metrics give us a flawless, structured way to quantify an invisible empire. We now know exactly how utilities define their operational scale. They count the distinct residential, commercial, and industrial properties served. They break down the exact percentage of where their water is sourced from. They track the thousands of cubic meters delivered and the average daily wastewater treated by sewer type. And they measure the thousands of kilometers of water mains and sewer pipes making it all happen. By using these activity metrics to define their sheer scale, utilities give us the baseline we desperately need. Because only when we truly understand the massive scale of these systems can we finally ask the most important question. Are these invisible, critical networks sustainable and resilient enough for tomorrow?